Hi, I'm Bianca Coker, and I'm going to give you a few of my insights into some of the new standards. Today, we're going to talk about 7.4e. That standard says that the student applies mathematical process standards to represent and solve problems involving proportional relationships. The student is expected to convert between measurement systems, including the use of proportions and the use of unit rates. So first we're going to look at how to use proportions to convert between different units. If we start with a problem like 256 inches equals an unknown number of feet, and we want to determine how many feet this distance is, then we can use a proportion to do that. And the way we do that is we set up a ratio of something we know. We do know that 12 inches is equal to 1 foot. And we set that ratio equal to another ratio, 256 inches, equals an unknown amount of feet. We can put an X there, we can put a question mark, whatever you do in your classroom. Now that we have this proportion, these two equal ratios, then we simply solve it the way we would normally solve a proportion, in all the different ways that you've been working with your students on solving proportions. One thing students sometimes struggle with is how to take these two equal quantities that are presented to them either in the formula chart or given to them or as something they know, like 12 inches are in 1 foot, and how to set up that ratio or that proportion correctly. The one thing you want to probably tell them, and as you have with other proportions, is that you want to match up those units. If you have inches in the numerator on one ratio, then you want to have inches in the numerator on the other ratio. So in this case, I have inches to feet, so the other ratio should be inches to feet. If they have those things matched up, they'll get the right answer once they've solved the proportion. Another way to solve conversion problems is using unit rates. In this case, we'll start with the same problem, 256 inches equals an unknown number of feet. To use a unit rate, though, we're going to use an equality like the 1 foot equals 12 inches, and we're going to set it up as a ratio or a fraction in this case. But this fraction has a special quality. Because the numerator is equal to the denominator, then that value is 1. Anytime we have the same number in the numerator and the same number in the denominator, the value of that fraction is 1. And as we know, and hopefully your students know, when you multiply something by 1, you don't actually change it at all. We might change the look of it, but we don't change it. I used to tell my students, I'm the same person, whether you not call me Mom or Mrs. Coker or something else. We won't talk about that. But in this situation, we're multiplying by 1 in the form of 12 inches over 1 foot over 12 inches. And when we do that, we'll also notice that we have a lot of units floating around in our problem. Well, if we think about the inches divided by inches, that's also 1. And so it becomes not canceled out like we used to say back in the old days, but inches divided by inches is 1. And again, when we multiply anything by 1, we're not changing it. So what we have left is 256 times 1 foot divided by 12. And we can use that method then to solve our conversion problem. Now here's the formula chart that or from the reference materials that students are going to be provided on STAR starting in the spring of 2015. Notice that on this formula chart there are no between systems conversions. There's nothing equating a customary unit to a metric unit. So there's some discussion about among teachers whether that's really what they intended in the standard. I'm not sure what the intent was. I'm not sure how Pearson is going to test our students, but I'm going to make sure that my students are prepared to convert between the two measurement systems as the standard indicates. Even though it doesn't have it on the formula chart, we're going to probably prepare our students in a way like this. And perhaps this might be the way it's tested. If we look at a problem like this one, Ursula is traveling to Europe. She will be doing a lot of walking. While in Paris, she wants to walk the entire length of Champs-Élysées. Sorry if you speak French. Her guidebook says it's 1.91 kilometers long. She wonders how long this is in miles. And in the problem, in parentheses, it is noted that 1 mile is equal to 1.61 kilometers. So even though it's not on the formula chart, it could be provided within the context of the problem that the students are expected to solve. So the way we would set that one up is we would, as a proportion, say 1.91 kilometers over, or in the numerator, and an unknown amount of miles in the denominator, equals 1 kilometer in the numerator over 1.61 miles in the denominator. Again, we have that 1 ratio there. We have our equal proportion, we have kilometers and kilometers, miles and miles, so they simply do the math to solve the proportion and they'll have their answer in miles. The unit rate approach, we'll take the 1.91 kilometers multiplied by 1 again, and we want to make sure that in this case, miles is in the numerator and kilometers are in the denominator, so that we get our units simplified. Kilometers divided by kilometers is just 1, and all we have left are miles in the numerator. So simply, they just have to multiply 1.91 times 1.61 to solve for the number of miles. The question I have for you is, what will you do in your classrooms? How are you going to approach solving conversion problems with proportions and with unit rates? And I do have a suggestion for you. Find some of your science teachers on campus and ask them how they deal with conversions between units, because it is something that's done in the science classroom. It would be nice if we were all on the same page and all telling the students the same thing about how to do these conversions. And I can tell you that your science teachers will love you if your students walk into their classroom knowing how to do unit conversions. Thanks.